Hello and welcome back to another episode of the Oxford MAT Submissions Test livestream. My name's James and I slightly missed the timing on the introduction, but I got there with the enthusiasm. I'm joined this week by some of you live here in Slido chat. You can join in at slido.com/MATLIVE. And I'm also joined by Beth, who's a third year student at New College, which is my college. Beth's just finished third year. Beth's moderating chat today. So if you want to talk to Beth, you can talk to Beth. If you want to talk to me, you can talk to me. Things that you might like to say are, for example, hi, like Will says hi, there you go. But you might also like to tell me how your day is going, because I always like to know whether people are having a 1-star day, a 5-star day, or something in between. It's particularly interesting to me what the first few responses are, but there we go. Right, somebody was really fast. Finger on that vote. Right, okay, today, logarithms. Are they my favourite session out of the 8 of these that we're doing? Yes, I'm willing to go on the record and say that this one is going to be, I'm not saying the best, I'm saying my favourite. That's what I'm going with. I've got on the screen at the moment a list of logarithm facts. These are taken from the TMUA specification. Just while we're getting together at the moment, I noticed earlier today that the what's the word? Specification has been updated for exams in 2026 for the TMUA. All of my resources at the top say 2025 because that's the specification that I looked at. The good news is that the specification has not changed in any notable way, so we're all fine. I thought I'd say it in case anybody's noticed that 2025 was in the past. I guess I'll have to put a note on the website as well. I could go through and change all the 2025 to 2026s, but that's the only change I would need to make. Right, that's the wording that's going to go on the website. The website I'm talking about is the homepage for this thing. It's the place where you could download this PDF. You could scroll ahead and find out. So there's this last one. I'm just going to hide chat for a second. There's this last one at the bottom, which says, oh no, one before last. Sorry, that I want to point out. Yes. Questions requiring knowledge of the change of base formula will not be set. So there's this thing called change of base formula, and you don't need to know it. So helpfully in the revision notes, I have written out the change of base formula and reminded you that you are not required to know it. Tee-hee. One of my ulterior motives with the Math Submissions Test livestream is to perhaps teach somebody some maths. Here's a fact you're not required to know, but once you've seen it, how hard is that to learn? I don't think it's that hard to learn. No, you know it. Right, okay. The spec changed. Yeah, I've said not a notable way. If I'm being honest, they fixed 2 typos, neither of which is worth drawing attention to. So if you spotted any typos, they might have been fixed. But in fact, one of the typos they're not interesting typos. I'd already fixed one of them in the specification. So you were secretly already on the 2026 specification when you read it before, because I'd preempted the change. Right, good. Hello from Germany, says German Saddlers, which is a reminder to me that you can change your username we can't, as far as I know, we can't tell who's who between sessions. So if you've always wanted to try out a different name, you can give that a go, which is what German Saddlers is up to at the top. And hi to Lala, and Mary is here, and SB has joined chat as well. Brilliant, good, okay. Who else is here? We're joined by John Math, the inventor of maths. Nice to meet you, John Math. Invented maths and named it after himself. And Matty G. Good, right, nice to meet people. Okay, I think we should get right to it and we should do a warm-up problem. I have got on the board, I don't really know when people learn about logarithms. Possibly you already learned about logarithms, possibly you are learning about them live now, in which case, here's maybe not the best first question to learn about logarithms, maybe just look at the look at the revision notes first for a way to get some stuff, because I'd like to try and check people's understanding of logarithms. With this question, it says, what does log base 1/2 of x mean? Something involving x, something involving 1/2. What does this, I guess it's a function, what does this function mean? What's it doing? Hello to Matt L. Good. So I'm going to let people type in chat. This is my warm-up activity. If you've not met logarithms before, let me scroll. Logarithms are, this is spoilers, I suppose. Can I get this on the board at the same time? Chat's kind of hiding it, and I would like chat on screen at the moment. But it's to do with the solution to the equation a to the x equals b. Is blah 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 called log base a of b. Here we go. Yes, chat, brilliant. Lala got in first, but we're proving all of them. Yes. There we go. Yeah. So I like some people are giving it a name. It looks like Y is the average name to give this thing. So let's go. It's a number that depends on x. That's a weird way of saying a function. Let's call it y. Oh, handwriting. Let's call it y. Writing out what I can see in chat. And then it looks like people are telling me that the idea is the base down here is the number that is being raised to some power. The relationship is very precise. It's always the case that if you have an expression like this, that you can, this is a little bit like doubling both sides or adding 3 to both sides or squaring both sides. You do 1/2 to the power of each side. I don't think people really think about it like that, but 1/2 to the power of y, okay, I'll write that down. And then the sort of defining property, if you like, is the base to the power of log base anything. In this case, 1/2. So 1/2 to the power of log base 1/2 sort of cancels out, and you're left with this x. Said differently, this sentence here is definition of what this logarithm monster thing means. Okay, we can do a little bit better, can't we? So Violet in chat, yes, you want to find out what the something is. This kind of makes sense if you're meeting this for the first time, which might be somebody in chat. This sort of makes sense, provided x is positive. I don't know if you've ever really thought about 1/2 to the power of y. I'm going to try and do a little graph where, I suppose unusually, I've got y on the horizontal axis. So 1/2 to the y, if y is 0, that's 1. And as y increases, you're sort of halving as we move to the right. Or said differently, if you move to the left, then we're doubling, so you get this curve like this. And this is going to take every positive value at some point. So if you've got some favourite value of x, where incredibly I'm going to mark this on the vertical axis, I know. Letters are just letters sometimes, aren't they? Letters are just letters. If this freaks you out, then switch the x and y to any other 2 letters that you have less of an emotional bond to. It's the same page with different letters. Sorry, I'm being silly. Okay, so you've got some favourite value of x, and then that's the value that you want. This value, let's mark it on this axis here. This value is what you want. The one where if you did 1/2 to the power of that, you would get x. Right, yes, we would like the something. The exponent of 1/2. Good language. Exponent being the thing up there. Good. We can do a little bit better because, of course, you know that 2 to the power of -1 is 1/2. And then if you know about your powers, you can multiply these powers together to get, I'm going to keep working, downwards. 2 to the power of -y is equal to x. So in fact, this relationship works the other way round as well. That as well as being able to go from a fact like this about the logarithm to a fact about powers, of course, they go the other way round. So here, the thing I'm going to write is log base 2 of both sides, just to sort of keep messing around with the expression. I'm not really going anywhere with this, don't worry, I'm just messing around with logarithms. Normal Thursday night. So log base 2 on both sides. So log base 2 like this will give me this on the right. And on the left, log base 2 cancels out with this 2 to the power of. So the phrase log base 2 of 2 to the power of, all that stuff I just said collapses down. The inverse functions, if you know about functions and inverse functions, whatever. So just trying to minus y. This is brilliant technology, right? It lets you sort of undo powers, but not in the square rooty sort of way, in the other way. Yeah, people are making fun in chat of the y-axis being on horizontal and the x-axis being vertical. I actually think that's good for you. You have to see something like that once in your life. It's weird, isn't it? Right? So we got this like. Let's do it one more time. So it's on the chat. It's good for you at some point to see this picture where you're like, oh, weird. I started with some logarithm. My function was I put in a value of x, I get a function of y. And I started with a logarithm. It's almost like the axes are the wrong way round. So I started with a logarithm, and the axes are now the wrong way round, and I've got an exponential. Sort of like, if I flip them the right way around again, I'll get back to my logarithm. So it's sort of almost like an exponential and a logarithm are mirror images. Almost, because they are. Anyway, where am I going with this? The punchline down here, I suppose, has to be y equals, because, we started by calling it y, and we're very close to saying what y is equal to. Okay, it's another logarithm, but here we are. I'll zoom out a little bit. This line down here is going to be y is minus log base 2 of x. Oh, okay. So what does log base 1/2 x mean? A slightly silly answer is that it means minus log base 2 of x. Which of course doesn't really answer the question unless you know about log base 2. That is not one of the laws of logarithms on TMUA. This is not something you need to know. But on the other hand, once you've seen it, no one can take it away from you. Right, never know, you might need to do this. You're probably aware that if this is a 1 over x, you can put out a minus sign. Are you aware that if this is a 1 over b, then you can put out a minus sign? Seen it now. Nothing special about the, yes, lovely. Oh, you can put the minus sign inside. We can keep messing around. Shout out to best username I've seen so far. Log of smiley face. It's log colon plus log close bracket. Excellent stuff. Why is log base 1 over a x always minus log base a? Yes, there's nothing special about the number 2. You can replace everything here. Find and replace 2 with any number you like that's positive and that's not equal to 1. There's this rule of logarithms that all of the questions you see, I think, will just be fine, and this will not be something you have to think about. But log base 1 is not a thing. It's not defined. Sad face. That would be the answer to the question, what should you raise 1 to the power of if you want to get x? What power should I use? And this is not a good time, because powers of 1, they just don't work like powers of 2 or powers of 1/2, right? Powers of 1 are just boring. So unless x is equal to 1, I guess, you're going to have a pretty boring time. Even then, I don't know what value you should take. Yeah. Okay. The revision notes are full of these. Quickly hiding chat so we can look at them full screen. If you grab the revision notes from the worksheet, which is on the homepage, link on the screen, and link in the YouTube description, search for the phrase Math Submissions Test Livestream and it might come up. These are absolutely littered with things like this: a not equal to 1, and down at the bottom here, a not equal to 1 and c not equal to 1. And there's a fixed a not equal to 1 on the left over there as well. Because I'm trying to be correct so that I don't get emails, I have to be correct, right? I have to scatter all of these in, but I don't think you have to worry about it that much. Okay. Can I explain the 7th revision point? 7th revision point. All right. Okay. They're not numbered, are they? I've made that hard for you and hard for me. Can I explain the 7th revision? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's also true that a to the log x. Oh yeah. So this is a thing I've used halfway through here, because this one, it is also true at the bottom of the screen. 1, 2, 3, 4, 5, 6, 7. Let's put it at the top. This one? I hope you mean this one. Otherwise, terrifying news would be that I can't count to 7. Okay. So this is quite irritating because the thing I would like to show you is that so you have the function a to the x, and you have the function. I don't know if you like writing functions like this. I guess we've got questions like this, so we've all got to get used to it. But here we are, like this. I'd like to try and convince you in a couple of bullet points before that g of f of x is equal to x. That if first you do a to the x and then you change your mind, well, don't worry, you can do log base a of that. So this is the fact. This is the fact log base a of a to the x is equal to x. People usually write k here for like a power of a, but whatever. All the letters are a bit interchangeable. For the 7th bullet point at the top of the screen, I'm trying to convince you that also it's the other way around. That if you worked out log base a of x and then you changed your mind, well, you can do a to the power of x and you get back to x. These facts are actually different, not in a way that you need to worry about, but strictly speaking, you can't just switch f and g around. So you can't assume that you can. Whatever, never mind. It turns out you can. What am I saying? I'm trying to do this really carefully so that I don't make you think that in the future you'll be able to do sort of these big leaps of logic on other functions. I'm just trying to be careful. Right, okay. So what does this look like? F of g of x is this fact a to the power of log base a of x. The proof is kind of daft. I've written a couple of lines at the top of the screen there on the worksheet, where basically I just give it a name and then move things around and use the definition because, well, we're only on bullet point 7. We've kind of only got a definition and hope. These are our strategies, right? The definition of logarithm and hope that that's the relevant fact. And also the cunning trick of giving things names. I guess it comes down to this kind of fact that y is equal to log base a of x if and only if a to the power of y is equal to x. That definition is if and only if necessary and sufficient. Right, okay, that was fun. I haven't pointed at the product rule and the power rule, but you know, I think we're all right. Have I got the power rule down here twice? Oops. Maybe I do. That's embarrassing. I think bullet point 5 and bullet point 9 might be the same. Oh well. Yeah. They're inverse functions, so it's anonymous in chat. Yeah. I am trying to make the point that they undo each other. It is slightly subtle, but look, if you do maths at university, you will learn about the existence of left inverses and right inverses. You really should not worry about this at all. But one of them lets you undo the function after you've applied it, and the other one lets you preemptively undo it, which is probably not a thing you've ever wanted to do. And often those turn out to be the same thing. Here we are. Right, okay. This is mad, right? There's no chance that anyone watching this cares about left inverses and right inverses or needs to know this, but I feel I have to justify why am I doing this like this. It's good for you. Long term, it's good for you. Can you do base -2 of -8? Oh, it should be 3 without needing any complex solutions. It is unfortunately a world of pain. 3 would be a reasonable thing to define that to be. Log base -2 of -8. There might be other things that you can think of. Clue your thing. You're aware of complex numbers, I think. How wrong can things really go? Logarithms interact with complex numbers in a really quite weird way. There's loads going on there. Yeah, there's some Euler identity stuff going on, right? Like e to the I pi is -1, so e to the 2 I pi it gets you back around to 1 again, which means that you have like if you try and do logarithms with complex numbers, you have this weird problem that you have interesting statements involving powers and exponentials that are the same as each other with different exponents. None of this is on TMUA. I should probably get back on track. I think it is time for some revision questions. The way these work is that we have some show PDF. Ooh, I pressed that button. Nice. We were going to watch the animation. The way this works is that there are some revision notes, in this case just a page, and then there are some revision questions. The sheets are released the week before, so some people in chat have had the opportunity to have a go at the questions already and decide which ones we're going to talk about now. And just for maybe 20 minutes, maybe less, maybe more, depends how much people want to do, we are going to look at some of the revision questions, but not all of them, because I love logarithms and there are 19 questions this week. I can't delete any of them. I love all of them. So there's a vote going on in chat. Have I launched the vote? Yes, it's surprisingly slow to vote for 19 options. There's a vote going on in chat to decide which questions we're doing. I suppose this is exponentials and logarithms, but if I'm honest, the word exponentials is not really going to get much of a look in because, well, I thought, assuming a little bit that you're pretty happy with 2 to the power of 3 to the power of 4 is, let's do it together, that means 2 to the 3 times 2 to the 3 times 2 to the 3 times 1 more 2 to the 3, which works out to be 2 to the 12. The rule is that you can multiply the exponents in that situation. I'm trying so hard to say exponent for the little number upstairs and power for the combination 2 to the power of 3. I found out quite recently that I've been using those words interchangeably, but technically 2 to the power of 3 is a power and 3 is the exponent. Does it matter? Is this setting you up to succeed? Maybe. Right, okay, let's have a look at the vote. I'm also trying to have the questions a little bit on screen. It's not these ones that people are voting for, it is these ones down here. 19, 15, 16, 17. Oh, that's like a... Not 18. What's 18? Oh, 18 is fun. Oh, I like it. Looks down at 18. Oh no, my favourite. They're all my favourite. People want to do the last bit of the sheet. Yeah, that sort of makes sense. The part where the logarithms start getting really everywhere. Oh, are they in order? 15, 16, 17, 19. There we go. Got about a dozen people voting, which is nice. What happened? Yeah, sorry, I know that complex numbers just went... I sort of encouraged it as well because I read out the comment about complex numbers and then talked about complex numbers. If you're joining for the first time, for many years, since at least back in the day that Beth, who was currently moderating chat, current student, at least back when Beth was watching the live stream, getting ready for studying at Oxford, chat was obsessed with complex numbers, and it's always been like that. There's always not everyone all the time, but complex numbers seem to turn up quite a lot, even though they're nothing to do with TMUA or MAT. Ah well. Right, okay, I think the people have spoken, more or less. How's that vote for 9 looking if I scroll? It's pretty close, Can I have a quick look at 9? Oh, I'm not going to do 9. I'm not going to do 9, am I? 9 is to multiply out a whole bunch of things. There's a load of cancellation. It's supposed to be good for you. It's a sort of, like eat your spinach and you'll become big and strong like Popeye the Sailor. Multiply out all of these brackets and surely that will make you big and strong at multiplying out exponentials. I'm not going to do it live on the show. I'm going to point you at the solution, and I think I'm just going to wish you all the best with multiplying things out. I think I've set it up so that there's some cancellation. There's some like interesting things cancelling. And the second activity in question 9 is very similar to the first one. So possibly it's a test of whether you can reuse your arithmetic, but change some of the minus signs to plus signs and vice versa. You know, it's an option. Right, if people now voted for 9 on a sort of spite, what I did there was I said we weren't, and I left the voting open. That's an error, isn't it? Right, okay. 18 also, I saw that in chat, so we'll see how this goes. I'm thinking it's not that bad, right? So you've got 2 to the x, 2 to the minus x, 2 to the y and 2 to the minus y, with a minus sign in between. Okay, it is quite bad. Let's just do this bracket first. I know from experience not to multiply the whole thing all at once. So 2 to the x plus y from the first terms. Shall I do the outside terms next? Yeah, I feel like doing the outside terms next. Outside terms, and the inside terms, and the last terms, minus sign, 2 to the power of minus x minus y. Now it gets fun, because now the second bracket has a minus sign over here instead, and a plus sign here. So what's that going to change? Well, not the thing that I get from the first terms, because we're going to change signs over there. And then when I do the inside terms, the sign changes. When I do the outside terms, the sign changes. And when I do the last terms, the sign changes twice. Right, because it switched here and it switched here. But otherwise, I should just copy out these things from before. Oh, I should copy them correctly. You want me to add these? Well, because I was watching what I was doing, and I've done the terms in the same order, and I was mostly just copying these out. These things are going to cancel, and we're going to be left with 2 times, oh my goodness, this term. I said 2 minus signs, and I write down 1. So I caught myself. There you go. Everyone who voted for 9 at the last minute to make me do it, even though I said I didn't want to. Got it wrong. This is secretly a nice identity. It doesn't look nice in this format, but there's something going on with these like nicely balanced powers, or 2 to the x, 2 to the minus x. Something similar here, but with a minus sign. If you know a relationship between cosine of a plus b, then there's something oddly familiar about this. If you know a rule about cosine of a plus b, you know, you're like, I mean sine of a plus b. I think I'm changing my mind. You know, a fact about sine of a plus b. There's a thing that's just like up here we see an a plus b. It's sort of like a thing going on here where it's kind of same thing, other thing. Switch them around, put a plus sign in between. I didn't copy the question down correctly. Didn't copy the question down correctly. That will get me. Because of that one. Well, now I've got to do it again, haven't I? Oh, there are 2 questions on the board. I think I'm doing the first one. Did I switch to doing the second one halfway through? No, I think this is like fake news. I think I'm good. I think I'm good. I think I'm good. Yeah, good. Then there's a second one, which is about the same. Right, scroll away before I work out that there's a minus sign. I got the answer right, but copied it down wrong. And I did drop a minus sign halfway through. Did you see me fix it though? I fixed it. Is there a lesson there about mathematicians, right? Like, you don't necessarily get it the first time I write it down, but something about the fact, for a moment it looked like there were 4 terms, and 3 of them would cancel, but not the 4th. That's weird. It should be half of them, right? 4 is even. It should be half of them cancel, half of them don't. Not 3/4 of them cancel, 1 of them doesn't. That never happens. Right, okay. So question 15. Prove that. I'm going to rearrange it. So it says prove that this thing. How should we prove this? So 2 ways to do this, I reckon. One of them is to prove this fact. This is not quite what it says in the question. I know I'm not copying down the same thing as it says in the question. I'm rearranging it. So we could prove that these things add to make 0. That would show you that there's a minus sign. Or we could prove that log base a of n plus root n squared minus 1 is equal to log base a. We could move the minus sign inside. Okay. Either one would be good enough, because in the second case I would just bring out that factor of minus 1 from inside here. We've got something to the power of minus 1. And in the top one, this would be enough because I would just move this second term off the right hand side and then be done. In chat, can we prove it by induction? No, because it's not a whole number. I realise now that capital N makes it look like a whole number, but could be anything. In the first case, the way I would prove this would be to check that if I bring these logarithms together using the log xy fact, what's that called, the product rule, that I get 0. Seems like a thing I could do, I guess. Log a of deep breath times equals question mark 0. Maybe. And for the second one, I might check this fraction that I've just created. Can we like rationalize this? Depends how you feel about rationalizing fractions. Rationalize the denominator, right? What should I multiply by in order to get a nice denominator? Clue is the thing that is the same as the other way of doing the question. It is good that proving that a equals minus b is the same as proving that a plus b equals 0. It's good, isn't it? Sometimes if you need to prove that two things are equal, a equals b, you might try to prove that a minus b is equal to 0. But in words, two things are equal if and only if their difference is 0. Surprisingly useful idea sometimes. Yeah, move all your problems onto the left-hand side and try and glom them all together. If you do this, then this turns out to be, after multiplying exactly 1, like independent of n, just 1 in the brackets. Bit of a surprise. And then that really is 0. If you rationalize this, then you get exactly the same on the left. And your maths looks maybe a little bit confusing because you sort of know where you're going, so you know what to do. Or maybe you rationalize normally. Should we do this one in the brackets? Let's do it this way properly. So the brackets here are n plus root n squared minus 1 and n minus root n squared minus 1. What's the name of the trick that I should use to simplify that? It's not first outside, inside, last. I could do first outside, inside, last to get the 4 terms that you get when you multiply this out. Yeah, so German Sadler's says that for the fraction you can multiply top and bottom by n plus root n squared minus 1. Either you do that because that's how you rationalize the denominator, or you do that because, well, I know that it's supposed to end up being this, so this has got to appear somewhere. I don't know. Maybe I shouldn't be encouraging people to try and like jump to the answer. Yes, thank you, John Nath and Anonymous and the real Leonard Euler. Difference between 2 squares is a good trick. This looks like a plus b and a minus b. I shouldn't use a because there's an a hanging out down here, but you know what I mean. Difference of 2 squares. This is n squared minus root n squared minus 1 squared. Amazing. There we go. So this gives 1. 1. I just think that's neat. This thing sort of cancels perfectly. We have stickers for this live stream. So it really is 0. I can get rid of all the question marks. Oh no, I got rid of the sticker. So if you like, these logarithms are related. They don't look that related. It looks a bit implausible when you look at the question, that minus sign. What's this rule? It's not a general rule, but if you see a minus sign somewhere in your logarithm expression, you can move it out the front. That is not a rule, but it works here. There's one sign in between. So that's nice. Yes, and if you rationalize the denominator in that fraction, you get the same method, same answer. Okay. Question 16 starts a theme. So here we go. We are going to, over the course of, we'll do this together, over the course of 16, 17, we're going to prove the thing that you don't need to know, which is the change of base formula. TMUA specification, remember at the top, updated for 2026 now, still says you don't need to know this. We're going to have a go anyway. So the first hint of it is in this question with x to the y equals y to the x, which is pretty cool already. The question says use logarithms to turn this into all the x on the left and all the y's on the right. Same function in each case. You could do some sort of logarithm base x, or you could do some sort of logarithm base y. It's hard to decide, perhaps because it's so symmetric and nice. You could do a logarithm base 3. These all work. Which is maybe a bit surprising. The question says use logarithms, and you can use whichever logarithms you like. So maybe you like logarithm base 10, which gets used by some people. I think engineers like logarithm base 10, which is good. Maybe you like logarithm base 2 because you think that all numbers should be written in binary, and that's an acceptable opinion to have. Whichever logarithm you take, it doesn't really matter. I'm going to go for log base a, just to sort of illustrate that it really doesn't matter. Because you get to use the power rule on both sides. If you do that, then you get this. So I want all the x terms on the left. I've already got this on the left. You might do this the other way around. You might take, I could now do lots of things. So it says f of x equals f of y. It doesn't tell me what f is. There's more than one answer because your function might be this, but you might have flipped this upside down compared to me by doing the division the other way around. You could swap the left side and the right side before you divide. That sort of thing. You might double both sides. It's a true fact. If I put two both sides, so your function might be different from mine. And add 3, why not? But for me, the function is, I don't know, log base 3 of x divided by x. People who requested this question, I'd like you to notice that it's kind of weird that the base doesn't really matter. Like, you get down to a nice result anyway. You get some function, whichever base you pick. I think if you pick base, is this quite true? Because if you pick base x, then you will get some x on the right side as well, won't you, down here, which will be irritating and weird. And if you pick base y, then you'll get some y down here, and that will be irritating and weird. So maybe it's a sort of lesson to say choosing x or choosing y would break the symmetry between this. It's really pretty, like x to the y, y to the x. There's a forwards and backwards or something. Whichever one you choose will break that symmetry. You should try and avoid breaking symmetry if you can. Just in general, life advice. What am I talking about? Yeah, I've realised that these all work-ish. I suppose maybe a more accurate thing. Let's make this more accurate. I've gone off these ones. There we go. Uncontroversial that log base 10 works, log base 2 works, log base a for anything. Am I correctly mind reading what people did for this? Did you do logarithms base x, logarithms base y? And then it's a bit of a mess? Is that like the correct soul read? Not kidding. Chat's normally very chatty. Chat's gone completely silent since I saw this question. Am I cancelled the live stream? Are we fair? Yeah. Oh, right. Okay. Okay. Chatting as well. Move the Pete back on screen. It comes in log with no base. Yeah. Ooh, a general one. I wonder if the general one also. Oh, good reminder as well. You can be anonymous as well. You don't even have to type the word anonymous. Yeah, right. Okay, so you're asking about sketching the graph. Okay. Yeah, general one. I don't really know if I believe in general one. Everyone has to say what they mean. So you do sometimes see people just talking about this, right? But then it's a bit ambiguous because I think the engineers write this to mean log base 10x because that's on your calculator or something. Whereas mathematicians write this to mean our favourite one, which is, let me make a little bit more space to show you my favourite logarithm. The kind of one, just such a natural choice of number that often we don't bother writing at all, which is 2.71828182845904552 ... forever is an irrational number. Like the obvious choice. Are we all mad? Is that how mathematicians just anyway? That turns out to be such a good choice that we always mean that one and we don't write down the number. You might need this at school, and at school they won't tell you that because that's obviously ridiculous. They'll invent a new name and they'll tell you it's lnx, to hide you from the truth that mathematicians have decided not to write 2.718281245904552 ... forever because we use that number so much. We call it E. It's not on TMUA. That, mark the counter. I haven't done an hour yet. That's already about 3 or 4 things that are not on TMUA, will not help you with that admissions test, for which I've told you about anyway. Place change, complex numbers, Euler's identity. We did a hyperbolic trigonometric relationship, but I think I got away with it. Natural logarithms, E, oh dear, it's actually 6. Right, okay. I'll try and stay on topic. How do you sketch this? What does this look like? So actually it depends what you picked for A. If you picked a number between 0 and 1, then marvellous choice, well done. Everything still works, but your graph is going to be the other way up compared to mine. Don't email me. You can email me, but not about that. Email address in the YouTube description if you want to give me advice about how to draw a straight line. Oh my goodness. Oh no, don't actually email. I know there's a tool. Just don't. How would I sketch this? So I've got something like logarithm base something, maybe anonymous, some number that's close to 3 or maybe 3. Well, I know what that looks like because I've had to sketch it before. We've got a graph sketching episode in 2 or 3 weeks. The remaining ones are differentiation, integration, and graph sketching. So in 3 weeks we'll do some graph sketching. I'm saving this graph for the graph sketching. And then I'm supposed to divide it by x. So kind of dividing by x over here is going to make it even larger values. So very negative down here. So I need to somehow make this more extreme. 0 divided by x is 0. So I'm going to draw something that's a bit steeper. And then after a while, what's going to happen? So for very large x, logarithm graphs slow down. They grow slower and slower. You're supposed to have some shape of a logarithm graph in your mind, I guess. They slow down, going slower and slower. While x, famously, just keeps growing at a steady rate. This means that eventually, when you get out to, I don't know, 1 million or something, the logarithm is pretty small, and 1 million is 1 million. We've got like something quite relatively small divided by 1 million. What I'm saying is that for very large x, this is going to be tiny. So then the thing I would sketch next is something that sort of goes up and then changes its mind and comes back down again. And I really can't explain how negative it is just off the screen over here. You can't see, but it's so negative. Yes. Right. Oh, right, okay. I've been trying to, someone says, been trying to differentiate this with the Yeah, okay, so depending on which one you chose. If you chose base 3, you're going to have a hard time differentiating it, perhaps. If you chose base E, then it's easy to differentiate. And that, joking aside, that is one of the main reasons why mathematicians use this particular number. And that's one which has a nice formula for that derivative. The thing I'm describing where the gradient gets less and less steep. Again, not on TMUA. Yeah, natural logarithms. I'm a bit surprised they're not on TMUA. I'd never noticed before this year, but the sheet is exponentials, and you don't learn about, well, mathematician test and TMUA were very slightly different tests. Mathematician's test always assumes that people have seen e to the power of x, and TMUA does not assume you've seen e to the power of x. German settlers was taught that if no base it means 10, the exams definitely should, otherwise people like me will complain. Somebody with first name matrix has differentiated it. I think they made the choice to use natural logarithms, which, good. I'm going to prove it. Beth's holding it, but I'm going to prove it. The number E, so let's highlight that, sorry. The number E is not on TMUA in any form. I find that a little bit surprising. A few weeks ago, somebody asked if you could add one thing to TMUA, what would it be? I think it might be E. But that is also my bias that I really like logarithms. So I think I giggled when I saw the question because I would make the logarithms bit more so. Oh well. We don't know. So here's a question at the top. What score do you need on TMUA for strong application? We don't know because we've never used TMUA before. Please score as many points as you can. The higher the score, the better. We're not going to do our decisions just on TMUA. Not how we were using MAT before. We're going to look at the rest of the information we've got. But I expect the more marks you get on TMUA to be seen as a good thing. Because you're doing maths, and that is rather the idea of the maths course as well. Say hi to Mr. Marriott for me. Right, good. Yeah, there's something going on. Right, yeah, I worried about this. Thank you, Rebecca. Did you see me worry about it? Should it not go above? I think you might be right. Yeah. Because I'm dividing by x, right? Should it be lower? Oh, I shouldn't have committed to drawing these on the same axes. I'm not going to move it. I think Rebecca's right. I think that divided by x should have made this graph smaller. I seem to have drawn it getting larger. Not to the same scale. Yes, because this is 1, isn't it? This is 1, and then after that point, I'm dividing by something larger than 1, so it should get smaller. Right. Hello, if you've just joined. Right, okay, so we are moving on to a different question. This is first time we spot in these questions that actually base seems to not matter sometimes. And then 17 has got this sequence within it. What are we going to do? We're going to do 5 minutes of this, I think, because I want to smash through 17, 18, 19, just to hit some logarithms points, because these are the hard ones. Then we can do some TMUA. It's going to be great. So a to the k log base a of b. I wrote it like this to try and sort of almost frustrate you. If only that a to the power of was next to log base a, because we agreed earlier that inverse functions, if you have the phrase a to the power of log base a of, all of that cancels, goes away, and you're just left with what you have. But frustratingly, there is a factor of k in the middle. How can we get rid of it? How can we make it get out of here? Well, we could use some power laws, or I suppose the fact that multiplication is commutative to multiply it the other way around, right? And now I'm happier because now it really looks like I have a of b all to the power of k using some sort of like power law stuff. What I'm trying to do is I'm trying to rearrange it to get a to the power of log base a of, because that Just leave me with B. Right, okay. Sorry, first part. Right, okay. So this power is sort of just a fact you've seen before to the power of K. I think. Hello, if you've just joined. Question. Oh no. We're doing question 17, which is at the top of the board. My attempt is at the bottom. I have a text setup which should let me scroll them independently, but it doesn't always do what it's told. Right, okay, next up, we're asked about, well, it's called x, but I'm going to go for a to the log base a of b, log base b of c. Now, I am lazy, so what I would like, really, more than anything else, is to just do the same thing again, or to reuse the thing I was just doing. And also I see that this says a to the log base a of b. Okay, there's some more stuff, but I can do the same trick again, look. Log base b of c, tee, there we go. So same trick again, this power of k or whatever, just goes over there. And then I'll be left with b for log base b of c. Oh, wait. So this is sort of the same, but with k being replaced with log base b of c. And then I get to do it again, don't I? B to the power of log base b of all cancels out and look at c. Yes, I just get down to c for what this is. Which means that we have, if you really squint, we have an equation from over here to over there, which reads a to the power of yuck something is equal to c, which is a long-winded way of saying, definition of a logarithm or something, that this power, whatever it is, rats, this exponent, whatever it is, I shouldn't have told you that I knew the difference. This exponent must be equal to log base a of c. That's maybe hard to see, but I am trying to point out that this is a to the power of stuff is equal to c. That's the same thing that we would say if you take log base a of both sides, perhaps. Then you're left with all of this. I know it looks like a mess, but I'm treating it as one block where I copy it all out. I've just log base a of both sides. And log base a of a to the power of goes away. Nothing to see here. I'm on the right, log base a of c. Okay, the reason I'm doing it is just really because I want you to look at this expression and look at how nice it is. It says log base a of b, log base b of c is equal to log base a of c. This is just a nice fact, and it lets you change base, so we can do some division. The question wants us to divide through by this term, put it over here, to get that fact on the board at the top. And that's the change of base rule, which you are not required to know, but look, it's like the other facts, right? Like the other facts, it comes from the definition of logarithms, because that's all we've got. We've got the definition of logarithms and hope. So you need to prove something like this, then that's really all you can do. It is the change of base formula. I have cheekily told you it and asked you to prove it. What a rude thing. Anonymous person in between, I did see this. So an anonymous person in chat says, in the worksheet you've put loads of cautionary, a not equal to 1, or a positive, and so on. And the thing I said earlier was that if I get any of these wrong, or if I miss any of these cautionary things, then I will get emails. I feel like, personally, maths background myself, right? I spent years trying to get things correct like this, including doing research. I feel like I should keep doing that, where I try and get it all actually correct with the terms and conditions. I don't think you should worry about this while you're doing maths. Like if you have to do a calculation like this, I don't think you should worry about it. I think you should be aware that the base of the logarithm has to be positive and it's not allowed to be 1. I mean, that's almost never going to come up in your life, I think, but it's a fact that you should be aware of. Kind of a little like safety rail somewhere where if you see a logarithm with base 1 or a negative number, then something's gone wrong. I've tried to put all the safety rails in the document because I really don't want you to fall off the edges. You will be upset with me if you fall off the edges. I've got a kind of duty of care. Right, good. Hello, Epic Dragon. What's this? Graduated Cambridge CS. Congratulations. You come back. You came back. Epic Dragon with a Cambridge degree. Nice to see you again. Right, good. We've proved the change of base rule. We can do stuff with it. Question 18 actually gets us to like do this thing, which will be quite hard if I put it back up. It's an extension of this thing in question 8 where we have this pair of logarithms. So we have log base 6 of 45, and we want to write that in terms of log base 3 of something and log base 3 of something else. Is this on screen? Yes, just about. Let's hide chat. There we go. Log base 6 of 45, right, okay. So the observation is that, this is so good, right? Once you've seen change of base formula, because the things that we want, A and B, both involve log base 3. So all of the kind of laws of logarithms that you learn for TMUA have the same base everywhere. Not the thing in the starter activity. Did you see? We changed that log base 2 to log base 1/2, or maybe the other way around. But the change of base formula gives you another way to convert, because you're allowed to introduce whatever base you like here. It's so good. You get to choose. This is a true fact. This is a true fact. This is a true fact. You can put any number there that's positive and not equal to 1. Safety. So then they're base 3, and now it becomes a bit like question 8, where I have things involving log base 3, and it's just fun because now it's a question about factorizing these numbers, right? Log base 3 of 3, log base 3 of 2, I guess. Log base 3 of 9, log base 3 of 5. I think we've got names for some of these things. This is B, this is 2, this is 1, this is A. There's an expression involving A and B. I just think it's neat. It's one of those ones where you can use whatever base you like to do whatever logarithms you've got. You can just convert. I really toyed with the idea of not telling you about change of base formula because it's not on TMUA. You don't need to know it. But I think it's a case where if you know it, then some of these questions just cannot challenge you because you have this kind of parachute you can open, which is if you don't like the base on the logarithms in the question, you can convert them. That won't always help. It might be more work than the thing you're supposed to do, but it's a kind of escape hatch if you don't like the logarithms in a TMUA question. Right, yes, Anonymous in chat wants to know, how did the Epic Dragon find this live stream? Personally, I assume they're still subscribed and getting the notifications. Don't forget to click the bell so that you can be told about MAT live streams for the rest of your life. If you like. Or don't do that, that sounds mad. Right, we're going to take a very quick breather. If you've been looking at the screen for the last hour, remember to look away from the screen. I'm going to drink some water. Suggestion that you do the same if you like. A quick shout out to Beth, who is doing a great job of running chat. So look after chat messages coming through. The plan after I work out how oh my goodness. The plan after this quick hydration break is that we do some TMUA questions. So I'm going to try and get those on screen ready. They look a bit like this, but I'm not just going to do them in order. There are 6 of them here. They involve a mix of solving some equations, doing some trapezium rule, sneaky appearance of the trapezium rule. There are some hints on the question which I'm skimming past, or maybe you'd like to see this enormous sum adding together some logarithm terms, and maybe you'd like to solve some equations. Maybe you'd like to hints. It's mostly scrolling this live stream. Maybe you'd like to look at these 2 very complicated functions. Or maybe you would like to do this question involving logarithms with unusual bases. Look, base x and base y. Those are the 6 things that we've got. Oh, did we skip 19? There was a 19. If a is negative, it's a decreasing function. The starter activity where we switched between log base 2 and log base 1/2 shows that you just get a minus sign. Yeah, it just flips the graph upside down. So instead of increasing, it becomes decreasing. That was a case where I added a safety rail, added a kind of safety net thing to the revision notes, and then put a question on to ask you why there was a safety rail there. Good fun. Right, okay, there are 6. We do this by audience vote. It's just about going to fit, isn't it? We're going to do this vote. There we go. So there are 6. I think to start off with, they're in the correct order. I don't know what happens as you start voting on them, but so the question sheets get released a week in advance. The one for differentiation, for example, has been put on the MAT Live website today. If you want to get a week ahead, you could have a look at the differentiation questions at some point between now and next week. The solutions have also been published, so I don't know. If you don't want to join in with the live stream, then that is an option. It's been designed so that you can completely ignore YouTube and still get some questions, some extension ideas, some hints and revision notes. This is maybe the only YouTube live stream where there is an entirely resourced alternative. So all of the support that you might be getting, all of the support. I stay on topic a lot more in the printed notes. Right, what are we doing? At the moment, it's the last question that's winning, but the first question is doing quite well. So I don't know whether I should scroll up or down. Am I going to bias it by having this one on the screen? Let's find out. What's chat talking about? Can't find chat. Where's chat on? Chat's talking about question 19. So options for question 19. I sort of just told you it was a decreasing function there because of that minus sign. So options, you could use the change of base formula, which will have, if a is less than 1, then you can sneakily try and change that into a 1 over a. So you can use the change of base formula to achieve that. First step, choose any base that you like. And you've got log base that of x upstairs, and you've got log base, whatever he said, of a downstairs. And now, sneaky trick, you can change that to 1 over a there if you put a minus sign on the front, because log base anything of 1 over a is minus log of a. It's an example of the power rule, isn't it? Then that minus sign means that you're switching this function from being an increasing function to a decreasing function. I would recommend Desmos at some point, I think. Beth says that there's none of my shining personality in the notes, and that shows that I need to try harder, because this year I've tried, oh, should I say this out loud? Yeah, let's say this out loud. I have tried quite hard to pass the Turing test with the notes. If you read the hints or the worked solutions, I have tried to make it really clear that I'm a human who has done these questions, and I'm telling you how I did the questions. It's not the case that they're written by AI. They are genuinely written by me. Right, what am I doing? I'm doing question 6, which is the one on the screen, which would be very convenient. So I think I'm going to pause the vote there. Oh, look, is it actually done really well, isn't it? Really well, 52%. Wow, that's actually a majority. Is it the first time we've had a majority? I'll have to watch the replays. Right. Okay, well, we're doing this. that's that. Right. I'm over-indexed on change of base formulas. So, okay, I'm going to hide all the options. Let's have a quick look at them before I hide them. All of them say log base z of x on the left-hand side, and they have some simple expression that doesn't involve any logarithms on the right, I'm not going to try and understand them. They're all different, because that's how multiple choice questions work. We will know it when we see it, because I want a bit of whiteboard. We know that, and then I'm going to convert these facts. So, golden rule with logarithms, I suppose, is that you always have the ability to turn them into facts about exponentials like this. I just think that this is, maybe underrated, that you can switch between them. So in the question they're presented as logarithms, and it looks a bit scary because, they're like, that's what they're like. Base x and then base y, so it sort of switches from being the variable of the function to being the base. Normally the base is held constant, so this is a bit weird, but as soon as you turn them back as powers, then maybe this is a bit nicer. What do I want? I want a lot of things, but one of the things I want is an expression for log base z of x, which would be something to do with what? I guess powers of z. I didn't mean powers. And there should be an x on the right hand side, or on the other side. Right? Like the last step of my work has to be something like take log base z of both sides, and then I've got, oh brilliant, log base z of x, and it's equal to, and then I'm looking at it and I see it and I'll have the answer. I'm trying to visualize, eyes on the prize. What's that last step of algebra like? And it kind of has to be, we're obviously going to mess around with powers now, and we could do that blindly, just start substituting or start square rooting or start adding things together or multiplying them all together. But it's good to know what we want, which is I want a power of z equal to x. If I see z to the power of equal to x, then that's the correct answer to this question. That's what I want, because my final triumphant step, take log base z of both sides, and log base z of z to the power of cancels, just to leave me with whatever that is, and the thing I'm looking for on the right hand side. So this is kind of my dream. And the dream was powers of z and x on its own. So I want to get x on its own. And I could get an x on its own by taking logarithms over here, but that would undo the only thing I've done so far. I don't think it's time to walk backwards yet, so I'm going to look at this one. So my mission, get x on its own. Everyone in chat is doing brilliantly. One reason that chat is hidden right now is that you are all correct. Yes, brilliant. So Anonymous says eliminating y. Ramshot has typed out quite a few steps. Ooh, yeah. Substitute. They've numbered the equations. Lovely. To sum one into. Yeah, they're doing some flipping things around as well. Oh, it's good. I like that one. Yeah, we need one base of z and one base of x. I've got some z's and x's in my diagram over here. Good job, chat. So I should probably do something like, I don't want to introduce logarithms just yet, I want powers. So I'm going to do something like y to the 1 over z is equal to x. So I think if I'd just done that step, it would have looked really weird. I really want you to know that, I don't know, if we're doing a lot of maths problems, doesn't really give you the ability, or at least not for me, doesn't give me the ability to look at this problem and go, oh, I want to take power of 1 over z on the first equation for reasons. I have to actually think of the reason why I'm doing the thing. Where am I going? What will it look like when I get there? Okay, so I've got x on its own. and then grr, this is a power of y. I don't want powers of y, I want powers of z. So now I'm thinking, oh, I want to use the other equation. I haven't used it yet. I don't want y. Don't like it. So I'm ready to eliminate y. Okay, what is y? Y is z to the power of y over x. I guess I've done this once, I'll do it twice. I'll just plug that in, and then I think I'm done. So it's quite nice, right? If you visualize where you're going enough, then it becomes more clear what steps to take. It's a little bit like working backwards, except obviously working backwards would just give me fuzzy feeling is equal to answer. That's not, I don't know. It's very hard to guess what fuzzy feeling is going to be. Yes, EJ has got a different approach in chat. This is the other reason chat's hidden. Yes, okay. There are other routes through this maze. I am trying to do the one where I can explain how I thought of what to do. Maybe you found a different route through this maze by just trying other things, like eliminate y seems really good. I don't know how I justify doing it. Possibly log base z of x doesn't look like it involves y. I mean, it could, but we're given some information that relates those things together. But it seems like some people in the chat just took this, put it in there. That'll get rid of y, and that works really well. That works really, really well. But I didn't feel like I could justify doing it. So okay, so I'll plug that in. I'm ready to do that over here. You know, it's all sides of a rectangle, right? The same sort of thing in the end. That's terrible handwriting, but I think you know what I mean. I've now got z to the power of something is equal to x, and that has foretold up here. Oh, perfect. I'll just choose the one that says this. 1 over xz, which looks like, there it is, f. And now it's time to reveal what chat's up to, because chat has got same thing as me at the top. EJ at the top says, just use the change of base formula, right? The thing that we just proved in question 17. Question 17, we in the revision material, we proved that. We proved that log base xy log base yz is equal to log base xz. Oh, that is the wrong way up. Okay, interesting. Okay, interesting. Maybe I need to be slightly cleverer, but so in the question, so this is the sort of thing that we know from change of base formula. Instead, that was x. So right, isn't it? It's a good start. This is not quite what we want, but change of base formula is actually really good. Change of base formula reveals that you can flip these things around. If you flipping these around just turns the whole fraction upside down, because this is secretly a fraction. This is secretly log base 17 of z divided by log base 17 of x. Why 17? Why not 17? Change of base formula is so good. Which of course then you can flip upside down if you want something that looks really struggling to write 17. Why not 17? Because you can't spell 17, James, or z. Oh, having a nightmare. This, right? And then that bit inside rejoins together. That's not what you mean, is it? Yeah. This fact at the top. Yeah. There's another fact which you might like, which you can prove using the change of base formula. So we had something that looks like this shape in question 17, like this. But something you might like is the following sort of amusing fact. If you go round the loop like this, then everything cancels. If you like, these things are secretly fractions in log base whatever you like, maybe 17, and the fractions will cancel. The change of base formula also sort of reveals a little bit why you write it like this, with this one downstairs a little bit, because it's secretly something to do with the denominator of the fraction. It's secretly just a fraction. Sort of. Yeah. Good, right. So if you know this fact, then we've been told that this thing is z and that this thing is x. And if you know the product is 1, then what's this term here? It's 1 over xz. So it sort of feels like TMUA questions don't require a change of base formula, but the change of base formula is so good that I think that if you know it, and surely by now we've been seeing it in several forms, surely you've seen it now, I think it's so good that it might just make logarithms questions easier for you in general. Maybe not all of them. Let's try. For example, question 5 fixes the base of the logarithm is 2, so no funny business there. Not much point doing anything clever. It's a good fact, isn't it? If you like this fact, then you might like the extension activity. Right, I think I've rather given things away. So for this one, the extension activity, by the way, this is in the solutions document. So, can I get this back? No, I don't know what I've done. I've put it there, but not there. There we go. We got there in the end. Solutions in the solutions document. So you get my solution, where I've tried to be human. I'm trying my hardest. And you get some extension ideas. So for this one, I did it 2 different ways. And then the extension idea for this one has formulas like down the bottom there, so challenge 4 things. Still multiplies to give 1 with this nice pattern. And then there's one of my, if I were using this as the start of an interview question, then next I'm going to ask you to continue the pattern. What's going on here? Maybe you can state what that pattern is. Right, 2 things happen there. I tried to show you the solutions, which is always really tricky on the setup that I've got. And I think I lost connection to the internet for a second. So possibly that little technical maneuver was not seen by anybody, but that's okay. Right, I think it's all back. We're right. Where were we? Oh yes, somebody said that's so elegant. Good. We're going to have a quick look at the vote, I think. So sort of question 6 at the end. Totally mad. Oh, a big purple flash there, wasn't there? Right, okay. One day I will work out how to do my tech better. Okay, what was the voting then? So people voted for 6. People also voted for 1 and 5, and the vote was kind of tied. So I'm going to put 5 on the screen. I'm going to, which is this thing involving these 2 functions, and I'll remind you that question 1 involves some sort of powers of 2 and 8 and 4 and 16. I'll leave the voting open to see if we want to do question 1 or question 5 just for a moment. Sorry, I sort of ran out of steam there. I get really scared by the disconnect notifications. Although I think they're constantly happening and we're surviving it. Yeah, somebody voted. Give it a moment in case it's not just one person voting. And no longer tied. Yep, we've had a tiebreaker. We're going back up to question 1, I think. How was people's day? I don't think I reacted to the previous poll, which is, how was your day? People having a pretty good day. 4.2 stars, pretty good. Right, okay, back to question 1. The people have spoken. Like a good tiebreaker. Sorry for all the scrolling. If you'd like a copy of the PDF, it's available on the website. You can find the website in the YouTube description, or by looking up the Oxford MAT Admissions Test Livestream, which is the name of the show. Right, I need to find chat, don't I? This one is quite tall on the screen because of how I've done the equations. But what are we given? We're given 2 equations, and we're asked for the value of x plus y. Can't remember if I've said this on the stream before, but quite often TMUA questions will have 2 things to solve for, in this case x and y, but then that will be slightly disguised by the fact that they're asking for x plus y. Not 100%, but almost every time I've seen one of these, where they're asking for b minus c, or what's the value of x plus y, involving 2 letters, almost every time you solve for both of the letters and then do whatever the thing is, like add them or multiply them or subtract them at the end. Very rarely you get to do a shortcut which tells you the value of x plus y, for example, without actually working out x and y. But this happens so rarely that I'm not going to recommend it as a sort of thing you should look out for. For this question, I think your reaction should be, I should try and solve for x and y. And with that mindset, well, you've got two equations, you've got two unknowns. If they were linear equations, we would just solve the linear equations by substitution. Sadly, they are exponential equations involving different powers, like different bases. 2, 4, 8, 16. So different approaches to this, because there's going to be a mix of dealing with the exponentials and dealing with the algebra to solve for x and y. And I think some people watching will have done this in one order, and some of it will have done it in the other order. I am interested in which one stood out to you. Would you like to start solving these, to like eliminate y, maybe? Or would you like to deal with the powers first? I'm being quite vague. I'm trying to describe strategies without telling you what to do. What do people do? EJ's in chat to say these. Yeah, so EJ's in chat to tell me about powers of 2 because there are some powers of 2 in this question, just a few. Maybe that's what everyone did. We'll do that on screen in a second. If people are happy with that being kind of consensus, they're all powers of 2. So we could use that fact to try and simplify things. Even the 8 in the denominator of a fraction is 2. No, okay. So Matt wants to deal with the powers first, but German Sadler's wants the other option, which is to solve for y first. So that first equation at the top there, the 8 to the power of y plus 3 also appears in the second equation. Annoyingly, there's also the 16 to the power of y plus 1. You can work with that. You can do things. I don't know. So if you take that second equation, I really doubt anyone's done this, but if you take that second equation and you multiply both sides by 16 squared, then on the left you have a horrible mess, and on the right you get, 16 to the power of y plus 3, and now there's loads of y plus 3. So now you can kind of do an elimination, right? Because 16 to the power of y plus 3 is just 8 to the power of y plus 3 all squared. So that was the thing we had before, but all squared. So you can kind of take that thing at the top and treat it like a substitution. I don't think this is the consensus approach. Sorry, but I don't think anyone's going to multiply by 256. Yes, no, I don't think anyone is going to multiply by 256. Possibly by 16 squared. Not by 256, even though those are the same number, but it's like non-obvious. I definitely haven't said this enough, but you should probably not multiply out your powers unless you have to. There's questions where you have things like 3 to the power of 4, and you should try and keep it as 3 to the power of 4. I think don't bother working out that that's equal to 81, because there's some chance that later you will divide it by 3 squared or something, and then you should demonstrate that you understand laws of powers, right, to be able to write that as 3 squared without ever working out the number 81. That sort of thing's good for speed, because there's nothing worse than working out a huge power of 3 and then realizing you need to divide by 3 a lot. Nothing worse. Okay, I think the strategy that's being described in chat, though, that is more popular is popular was one way of saying it, to turn everything into powers of 2, because 8 is secretly 2 cubed. Like this. And what's the other one? 2 to the power of 2, so 2 to the power of 2x plus 2. I'm being a bit careful, but not very careful. Famous last words. 2, 4, 8, 16, 2 to the power of 4. And down here it's the same thing again. So we've got these powers of 2. Right? So these equations tell me a fact about the exponents. Behind the scenes, if you want a little bit of a brain teaser, why am I allowed to do this? Why am I allowed to take this power of 2 on the left and this power of 2 on the right and say, yeah, forget about the 2s, let's just look at the exponents up here. Don't worry about it, right? Like, just do this. You know, like, if you've been highly trained that if you see sine x equals sine y, you are not allowed to just write down therefore x equals y. So not allowed that I've hidden it behind my own camera. There we go. So there are times when you're not allowed to do this sort of thing. You've got a function and I'm comparing the inputs. Brain teaser, why am I allowed to do that here? Powers with 4y and 3y, so y. Odds are high that I get one of these wrong. Have I got solutions? Oh, I have printed some solutions. They're over here and I haven't looked at them yet. What a waste. This one is everything's multiple 3. Okay, let's put an and in here, and then we've got this like diagram where it's and over this side, it's so going across. So it's a nice kind of square diagram. Yes, chat is telling me yes. Lala is correct in chat. Nice. Just going to solve these now. Yeah, you've got simultaneous equations. Depending if you have completed GCSE or equivalent, or if you're one of the people who is here during GCSEs to try and get ahead with maths, well, practicing this bit isn't really getting ahead because you're already doing it at GCSE. You can solve these equations. And it turns out that x is minus 10 and y is minus 13. Yeah, something like that. Minus 10 is, yeah, x is minus 10, y is minus 13. So the sum is minus 23. And we should pick which one minus 23 is. It's on the thing where I scroll, but I can't read. A. Good. Good. And chat has come through to explain. These are one-to-one functions. Good. Okay. Mumble, inverse function. Mumble is maybe something that might be nice to say. Oh, Anonymous has managed to type an if and only if symbol. So this double-headed arrow thing, you're using this double arrow to mean that there's an implication in both directions, like if and only if. Like if f of x is equal to f of y, then x is equal to y, and if x is equal to y, then f of x is equal to f of y. There's one of these, it's a bit weird, there's one of these in the specification. There it is, at the top. Can you see, just in the first law of logarithms up there, the defining law of logarithms. But they never define that symbol in the specification as far as I can tell. So I've been trying to avoid using it. It means if and only if. And personally, I think we've got enough ways to say that already without using the arrows. Learn them if you do maths at university, but there's nothing wrong with what you're saying. But personally, I'm trying to avoid using them. So I was a bit surprised to see that one there, but you know. Right, okay, that was one. Yeah, sine does not have that property. So the question, when does sine x equals sine y, is an interesting question with lots of answers. Because it's not the case that you just apply some inverse function and get x equals y. Sine doesn't have an inverse function. So what's the button on your calculator? That's really mean of me. I can't just go, sine doesn't have an inverse function. You've been told at GCSE or equivalent that you need to know about inverse sine, and inverse sine is the thing, but wow, it's tricky, isn't it? Right, okay. I think we do 5 next. I'm on a roll. What is it? 6:30. Here we go. Did they put the symbols in the logic section? I should have looked in the logic section. We will get there. My best guess is they copy-pasted it off a website somewhere. Right. Beth, you're undermining me. Telling the people with symbols that they look cool. Right. What are we doing? We're doing question 5, which is on the screen, sort of. Can I have a chat? I think I can have a chat. Oh my goodness. So, question 5 gives us two functions. They both involve logarithms. We might get to use some laws of logarithms to simplify things or unsimplify things. Don't be sorry, you're fine. Wait, no way to slide out of that. Have your keyboard in it. Wait, we're learning about Slido, or possibly we're learning about keyboards. Does mine do this? I want to go. So it's a game changer if we can do it now. I can. I'm not doing it now. I'm currently doing a live stream. I should not be messing around with Slido. Right, okay, functions. Here are two of them, f of x and g of x, involving logarithms. The problem here is that the options all read very similar to me, and it's really not clear when you look at that bank of options. What are we being asked? They just look like random inequalities that are all. Are these all different? Are they all the same? No, they're all. Are they all different? Or are some of them? The more you stare at it, the more different they are. But I'm wasting a lot of time just staring at the options. I should probably think about the question. But then I look back at the question, it's just two functions. So I think, oh no, I've got to understand the options in order to work out what I'm being asked to do. The options all have something in common. Can you see what they all have in common? Well, I guess they will have the word or down the middle. Who wants to say or down the middle? What's this? What's this at the top? Write the linear form of x is equal to, and then you don't mean x twice, but you mean, that's number 2. Huh. Does that work? I can't see how to do that for the first one. Maybe this person is just better at this than me. I cannot see how to do that for f. Wait, hang on, the arrows are good on one screen and bad on the other. Okay, good. Wait, this stuff in chat's brilliant. This is not what I did at all. Anonymous said, I let 2 to the f be this, and 2 to the g be that. So sort of using the outside one and using the defining property of logarithms to work it out. Do I agree with that? Do I agree with that? Evaluated at 4, just as a check. Where's the -1 come from? What could it possibly be? Divided by 2. Oh, yeah. What am I talking about? That's true, isn't it? Huh. Better at logarithms. These are all going to be the same, aren't they? It's another one where all these different approaches. I'm trying to piece together what people are telling me in chat, but these are all going to be the same, aren't they? So anonymous second down at the moment. It's got this 1/2 of log x versus on the other side square root of log x. So they're setting up this comparison between half of something and square root of something. And Ramjot in chat is turning everything into a function of log 2 log 2. I think that's going to be the same thing, but you're not going to write down any square roots because you've moved them all outside the logarithm, which I do agree you can do. Neat. Yeah. Okay. I think mine's more like, my approach I think is more like the anonymous approach, where because f and g both end with an application of log base 2, that makes them look similar. They're not the same. I would like to compare these things because every option has one case where f is less than or equal to g, and one case where g is less than or equal to f. Let me write that down. So just split screen for a second. So like the first one is blah 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 f of x less than or equal to g of x, or g of x, g of x less than or equal to f of x, blah blah blah, also something about 0. And then the second one is blah 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 g of x less than f of x, or f of x less than or equal to g of x, blah blah blah. And one case where f is less than g, and one case where f is greater than g, and we're required to say something else in either of those cases. But for me, this is my way in to work out what on earth I'm supposed to be saying. I'm supposed to be working out when is f less than g and when is f greater than g, because every one of these options distinguishes between those two and asks me to say more in each case. It's not obvious to me whether in the like small f case am I going to be saying that something else is even smaller, or am I going to be saying that something else is even larger than g? Is it one of this sort where, or is it one of this sort where that's on the left? I don't know what it's going to be, but I think I should work out whether f is greater than or less than g. I'll need the functions back on screen. There they are. So key question, I think, is f of x less than or equal to g. And maybe let's write that out as when is f of x less than or equal to g. And people in chat are going for it. Wait, is that true? F of x is just 2 times g of x minus 1. Big if true. Oh, that'll be great. Wait, we've combined with the things in the messages below you. I think that might be true. So then critical value when g is a half or something? No. When g is 1? Brilliant. You love to see it. Yeah, okay. People are willing to do a lot of algebra to simplify these expressions, which is good. I'm worrying that I'm in the wrong chair now. I should have chat. Take it away, chat, in your like 3 or 4 different methods simultaneously through Slido. I'm going to do nonsense things like, you know, I've got this thing is like they both involve a logarithm, so I'm going to do 2 to the power of to get rid of those logarithms. Maybe that's not nonsense, but that sounds actually quite a lot like some of the things in chat. Root x on that side and root log 2x on this side. So I can write that this if and only if log base 2 root x. I'm going to go under chat just for a second and then come back. You know, then I can go down this route and start sort of filling out factors of 1/2. Maybe I want to give this a name because I'm writing log base 2 of x quite a lot. So maybe I'll give that a name, and then I can start working out when this is happening. For me, it's a comparison between these 2 terms. But I totally see that if I'd move things further out the logarithms, like this 1/2 of log base 2 of log base 2 of x, whereas this is the one I hadn't spotted. Very impressed that people have spotted this. I didn't do that step because I didn't think I'd be able to deal with this factor of 1/2. I see now that because log base 2 isn't very nice with 1/2, isn't it? So this is log base 2 of log base 2 of x minus 1. That is brilliant. Does that help? Because then your comparison, you're going to give that a name. I'm over here giving this a name. You're going to give that a name. Or as Rebecca would put it, this g of x. It's not so bad. F of x is just twice that minus 1. Excellent stuff. Right. I honestly can't remember what I got for this. It doesn't have the options that all look the same when I look back. Anonymous person who wants to check it out. That's the answer I got as well. Okay. This gives us a way into the question at least. Although I sort of more respect everybody else's way into the question. Is it everybody else? super simple will be when f is big. Okay. So you'll see, I'm going to give this a name. U minus 1.5 u. Okay, people really like giving this a name. Call this u. Okay, we'll call that u. So is u less than or equal to, come on, is u minus 1 less than or equal to half u? And that happens, well, that happens when u is less than or equal to 2, right? So subtract half out of 1, double it. So then we've got to remember that u was log base 2 of log base 2. So I got the right number of these. That gives us the value. And then in those cases, you're not even going to go and work out the value of x, are you? You're going to say, oh, okay, and if so, if this thing that chat's calling u, I think, if so, then, well, you've written all your expressions in terms of this. So you can say that g, well, it's just 1/2 of that, is less than or equal to 1, and f is just that minus 1 is less than or equal to 1. So it's really easy for you to write down extra expressions. That's brilliant. That's very nice. So this is the case where f is less than g, and then both of them are less than or equal to 1, which is half of the statement in f. And in the other case, I think it's pretty obvious from these expressions that all of the signs will just flip all together. So if u is greater than or equal to 2, then g will be greater than or equal to 1, f will be greater than or equal to 1. That's very nice, chat. Right, what's chat saying? The u minus 1.5 u approach. There you go. Oh, I haven't sketched u minus 1.5 u. Sorry, well, I have this inequality here. So I did it with algebra, right? Maybe I should sketch it? Okay. Here's the u-axis. U minus 1, 1/2 u. And they cross over. I've still got to do algebra to work out where they cross over. U equals 2. So you've got this question, which is larger? Right, good axis. And you want a crazy axis. This is the chart that chat has invented. So we'll call it the chat chart. The chat chart is like this. You've sketched functions f of x and y of x, where your axis here is this expression, which people seem keen on, which is log of x. I think at some point in school, maybe you meet the idea of having a logarithmic scale on one of your axes. Chat's done that twice. It's like a logarithmic axis so much. Take another logarithm. It's basically my favorite thing. Logarithms so much, put logarithms inside the logarithms. And just to blow the mind of the person second from the top here, which could all be the same anonymous person. I don't like to assume. Is the derivative of natural log of x on TMUA? No, because natural log of x is not on TMUA. If you know about it, then that's nice. I really like natural logarithms, so I hope you're enjoying them. But the derivative's not on TMUA because the function itself is not on TMUA. And you can probably guess now that the integral of 1 over x is not on TMUA. Because you can't do that by adding 1 to the power and dividing by the new power. It's a shame, really, because the integral of 1 over x is something to do with logarithms, which would be such a nice fact that brings everything back round together again, but people don't learn it until near the end of A-level. So we might mess around with it on the integration sheet. I've quite enjoyed this, like doing other stuff, sort of thing. People in chat seem quite good at logarithms. Right, slightly different vibe today. I'm enjoying it. What have we not done? We've done 1, 5, and 6. We're on a roll. Oh, 15 minutes. Let's do another one. Oh, hang on. Shall I? Yeah. 1, 5, 6. Reset? Can I reset? Okay, I get a reset button if I do this, don't I? No, I don't. Pop. Yes. I can reset you. Haha. Right, okay. We can do another one if you like. I'll put the chat up. Put the thing there. Anybody wants to do one of these simultaneous equations? Just got to vote. I see you. If no one else votes, then there's just one person out there somewhere requesting what the next 15 minutes of this University of Oxford YouTube live stream is like. We kind of dodged pair. We dodged the trapezium. Well, no, they're picking the trapezium rule right now. Oh, you love to see it. Somebody else has logged into Slido and just agreed with the first person. I like that. Yeah, we skipped the pair 2 and 3. I don't mind if we talk about the trapezium rule now. We should talk about it at some point. I don't really know if people have met the trapezium rule. It's not that hard, but it's the sort of thing where you want to have. I think you want to have had a lesson on it in school or something, or you want to have thought about it before you start doing TMUA questions on the trapezium rule. It's just slightly fiddly, but not actually hard. That's all sounding very cryptic, isn't it? Let's see. Votes going all over the place, so I'm going to see how that goes. Right. Still so pleased with the chat chart. Logarithm of a logarithm as an axis. Sketch it on the log axis. They're going to like these. Trapezium rule is going to be part of the integration live stream, which is 2 weeks from now. So differentiation is out on the website. Integration will go up this time next week, and then the live stream happens in 2 weeks. You could look up the trapezium rule, or there's, what is that? Some slim chance that I try and say it now. I don't think I should try and teach you the trapezium rule right now. It's not horrible. The idea is that if you have some interval and you would like to work out this area, you've got a curve up here, you've got some equally spaced points down here, then how are you going to work out this area? It's got a curve at the top. I know, great idea. I will try and use trapeziums to make some approximation of the shape. So here's one of my trapeziums over here. It has some height on the left, it has some height on the right. How big's a trapezium? Oh gosh, well, you have to add these heights, divide by 2, multiply by the width. It's a whole thing. But that tells you how big the trapezium is. It is sitting next to another trapezium, equal widths, you see. So this one is exactly the same width as the previous one. And it's got some height, and I'm using the values of the function. So every time I want the height of the trapezium on either end, I'm using the function. So it's sort of like replacing your function with lots of straight line segments, and then you know how big trapeziums are, so off you go. There's a formula for it that people memorize. It's a sort of a thing, but we will cover it in a couple of weeks' time. Right. Okay, question 4 is 1. It was behind at the start, but it has come back with 70% of the vote. Which is like 7 people. But you know, I see there's 7 people. Okay, right. Well, okay, I think. Which one was 4? Is it this? It is this. Oh, this is fine. We can do this really quickly. 4 looks like this. Simultaneous equations. So my plan is try and solve these simultaneous equations. I would like to solve these simultaneous equations if I can. If I can't solve the simultaneous equations, then that's not part of the, yeah, that's the question, right? So what is the complete range of P? Let's talk about that. It means that we're only going to do one TMUA question right now, but when they say the complete range of P, they mean all values of p such that, then the following thing, whatever the rest of the sentence says. Another way they might say that is which of the following conditions is both necessary and sufficient. And I think when they say necessary and sufficient, people get a bit nervous because those are words of logic from the logic section of the TMUA specification, which we haven't put on the screen yet. But they are also English words. And it just means the same thing as this complete range of p thing. When we've talked about this before, this sort of thing, I've pointed out that they have to do something like this. Otherwise, they'd ask the question, for which values of p does this happen? And you might correctly think to yourself, well, p equals 3 works, maybe. You check that easy case or something, and then you go, well, yeah, p equals 3 works. P equals 3 might be sufficient, but it might not be necessary. So to make us do the question properly and actually work out which values of p, for which values of p, don't miss any values of p, and don't include any that are not correct. Just work out precisely which values of p. That's what they're trying to get here. And I feel like when it says it like this, with complete range of, or find precisely the values of p or something, people seem okay with it. So what's chat going to do? It's enough time. Is the plural trapezia? You can say trapezia or trapeziums. Either is fine. Right, so EJ wants to make a substitution, and not a mouse wants to rearrange to get log 2 of y, which is that's the split that I was trying to talk about with the simultaneous equations earlier. I'm just going to point and say EJ and a non-mouse up there. Those are your choices, right? You can try and deal with the 2 to the x and log base 2 of y in this case. Try and hide those or get rid of them somehow. So back in the previous one, we were considering, trying to maybe write a variable. I guess you could 2 to the power of x plus 3 or whatever. You could give that a name. Try and deal with that. Or alternative, you can just start solving. It's equations. Just go for it. Yeah, you're both right. You can just go for it. Anonymous at the top says, yeah, you just go and solve it. Right? Solve for x. Subtract the second. Yeah, it's just similar to equations. So for some people, they will probably prefer to rename things. The choice that I made to try and rename things was this. I wrote out but then I realised that this would be impossible to say out loud on the live stream because capital X, capital Y. At some point I'm going to say X or Y and confuse people. But if I'm being fully honest, this is how I write things down. X is equal to 2 to the little x. Y is equal to base 2 of y. This one is alarm bells for me because if capital X turns out to be a negative number, I might forget. I have to try and remember that if capital X is a negative number, then that is not okay because this thing is always positive. If capital X is 0, that's not okay. And whereas for this one, capital Y, yeah, well, whatever, it's fine. So I can go off and solve my equations in this nice normal looking shape, relatively normal looking shape. A bit shouty algebra, but relatively normal looking algebra. And the y value will be fine, but the x comes with this like uh-oh, so it's like exclamation mark. I just know sometimes they're going to give me it turns out to be a negative number, so right. Yes, okay. Oh, critical balance point. Okay. Yeah, just you sort of solve. They're not hard equations to solve. I think that's not really what's going on with this question, but you just start trying to solve them. And if you do that, then you get equations like this. I'm trying to draw a line between my equations. Drawing the line helps me remember which ones were given to me at the start and which ones I used to derive, which ones are kind of derived, so that I'm keeping track of which ones I haven't used, I guess, a little bit. Anyway, so if, so you'll remember, right? You'll remember. Is this going to be okay? There's a -1. The exclamation marks are getting louder in my head, right? That looks like it could be negative. So then the question, I think, is just, is that positive or negative? If it's positive, you're fine. If it's negative, you're not okay. And that is, I believe, the rest of the question. Because then capital Y can just do whatever. So if all is well with capital X, or this, what are we calling it? 2 to the x. If there really is a value for 2 to the x that is positive, then Y ought to be fine. Just do 1 minus that, and then I guess do 2 to the power of the thing to get rid of the logarithm. But we don't actually have to solve the thing, so it's sort of fine. That one's chill. If you've been here since the algebra sheet, or if you've caught up by going back to the algebra sheet, you will remember that I am always a little bit nervous when we do something like you're trying to solve x squared. I shouldn't improvise an equation right now, should I? You're trying to solve something like this. And we make a substitution. That always makes me nervous as well. Because we might get a negative solution for u. It's the same problem. We might get a negative solution for u, and then that won't actually correspond to a real value of x squared. I don't know if I've set that up right. I think I have. But we might get sort of negative solutions for x squared. So in this case, it sort of gets disguised, right? Have I done this correctly? I think I've done this correctly. So then you can maybe get excited and go like, I can factorize this. It's really easy because James has carefully made that a minus sign so that it all works. That was the question. Then so you go, right, okay, so u is 3 or u equals -1, but you have to check, right? You have to go check. Why am I not bothering about little y being negative? That's fine, isn't it? That's allowed. Little y can be negative. Oh no, it can't. No, it's fine. No, wait. Okay. I'm not bothered about little y being negative, and I'm also not worried about little y being negative. Here's what's going to happen. Y is equal to something. I don't feel like I've got time to work out what, but luckily it doesn't matter, because then from here, little y is going to be 2 to the power of that something, which is definitely greater than 0. So you see that subtlety, right? Like you get your solution out of solving some simultaneous equations around here. Oh, I'm going a bit croaky. You get your solution, and in one case, to turn that back into the variables in the question, in one case I'm doing 2 to the power of, which is very well behaved, and of course will give me something which I can then take a logarithm of. And in the other case, I'm trying to take a logarithm to work out lowercase x. Like I want to do this, and it's not clear that I'm allowed to do that, to work out lowercase x. It's not clear that I'm allowed to do that. So that's my concern. If I try and do this, I'm going to get not a real number, and then technically 2 to the power of that, whatever it is, will get me back again. But I'm looking for real solutions. How do I know big Y is positive? It doesn't need to be positive. Logarithm goes negative. Logarithm's lovely. Oh, that's under chat, but it doesn't need to be positive. So it could be a value over here. If big Y is negative, then that's okay. If big Y is negative, this is now the worst chart. Oh, after chat gave me such a good one, welcome to this horrible chart with capital Y on one axis and lowercase y on the other. If it's negative, that's okay. Just read off a value over here. If it's positive, that's okay. Just read it over here. But you see how I always get a positive value of little y, so I'm not bothered about the chance that little y turns out to be negative, and big Y can be anything. It's good. I'm just doing 2 to the power of big Y. It's my rule, and this is always well defined. It's always good. I think that's the difference. 2 to the power of y is always well defined, and log base 2 of x is sometimes not okay. Yeah, might be fun to chuck these into Desmos. I think if you just type them both into Desmos, you'll see what sort of graphs you get. And they might cross each other, or they might not. In some sense, you're taking some straight lines and deforming them, but that's kind of true of most graphs, so not an interesting thing for me to say. Good, right, you did it differently. Yeah, well, so I've made a sub and then solved. The alternative, I suppose, would be rearrange, solve. Yeah, other approaches are available. I've hit 7 o'clock though, so I think I'm going to call it there. Thanks for joining in with the live stream. Thanks for all the voting. Thank you for that fantastic solution to, I think, the hardest question on that sheet. That's very encouraging. I'm going to be back in 166 hours for another one of these. It's going to be on differentiation, which the worksheet, if you've enjoyed the worksheet but you just wish that it wasn't scrolling up and down so much, then you can get a nice copy that doesn't scroll itself up and down unless you ask it to. What am I saying? You can get your own worksheet. There's also an option to print one if you would like to print one, but we're trying to do web first this year, so the primary way to experience it is as a website that resizes nicely on your phone or whatever. Right, yes, okay. See you then. Take care. Have a nice evening. Have a nice weekend. And I'll see you in 166 hours, perhaps, for differentiation. Right. Take care, everyone. Bye.